Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing exponential functions. This is standard A.9D in the great state of Texas, and we are using item number 49 of the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a basic exponential function here, and we need to find a true statement. And you can actually do this without using your graphing calculator. Obviously, if you've got one handy, plug it in, see what it looks like. But we can actually tell what we need to tell simply from the equation here. So let's look at our standard form. Y equals a times b to the x. So this a tells us many things. If we were dealing with investments and compound interest, it would be your principal. If we are dealing with population growth or anything like that where something is either growing or getting smaller, we're going to be just dealing with your starting amount or your initial amount. But it also has a very nice feature, is that this is also the y-intercept. It's all of these things, and it's the y-intercept because that's where the graph crosses the y-axis when x equals 0. Well, look what happens when I make x equals 0 here. A times b to the 0. Right, I'm going to replace the x with the 0. Anything to the power of 0 is simply 1, so it's a times 1. So when x equals 0, y equals a. So that's good to know. Now this b here is going to be kind of our big, this is the big giveaway here. And in this case it's 2/3. But the b term is your rate. And it's going to be a growth rate if it is greater than 1. It is going to be a decay rate if it is less than 1. So we are dealing here with a decay rate. So let me show an example of each of these two. Okay, so your growth rate is going to look something like this. It's going to cross, and it's going to kind of just move up like this. Now, it's going to be really tight on this upward swing if the growth rate is really far above 1. If it's just barely above 1, it's going to be kind of flattened out. But it's increasing, it's growing from left to right. That's this growth rate. Here's what we're looking at right here. Is a decay rate, which means starting from left to right, it's going to decrease. Right? So it's going to kind of, and I'm going to kind of stretch it out a little bit. The reason I'm going to stretch it out is because it's this, this 1/3 is our principal. So that's where it's crossing right here. Is that 1/3? That's the y-intercept, and then you've got the actual decay rate of 2/3. So that's less than 1, which means it's starting out high, and then it's getting smaller, and then we're getting closer and closer to this x-axis. Now, for both of these, for most of your typical exponential functions, unless you do something like a +7 afterwards to like shift it up, or a -9 to shift it down, your x-axis is going to be your asymptote. For just your vanilla exponential functions, it's always going to be that x-axis. That's what it's always approaching, unless you do something like a +7 to shift it up or down. Okay, so let's look at our answer selections. No, the graph does not have a vertical asymptote. We can't say that this line right here is the asymptote for the increasing, or this line is the asymptote. It's going to continue to expand. It's horizontal asymptote. It's the x-axis. The graph crosses the axis at 0, 2, 9. Nope. That's your y-intercept right there. So it's not 2/9. It's 0 and then 1/3. The graph has an asymptote at 1/3. It does not. It's at y equals 0. The graph decreases, that's it. Because this b is less than 1, it decreases from left to right. Our answer is D.